welcome to the Data on Kubernetes community. This is we've hit over 30 meetups now at this point, which is very, very cool, exciting. We got a great track record. I was just telling Jim, we've got meetups planned all the way out now until June. Not all of them are uploaded yet on Meetup, but if you go and check out our community there on Meetup, we've got lots of meetups planned for the following weeks. I was telling Jim as well, we're going to have 2 meetups every week in March. We're also going to have 2 meetups every week in April. So plenty of content. You'll see the links on my screen for our LinkedIn, for our Twitter, also for our Slack. We have lots of conversations going on there. I was telling Jim that if we run out of time today, we will definitely continue the conversation there in Slack. So please feel free to get in there, ask any questions you might have. And anyway, like I said, we're always welcome to new ideas for new speakers, looking for folks that are interested in sharing knowledge. If you speak another language and would like to lead a meetup in another language, we're doing meetups in Spanish, we're doing them in Portuguese. I was talking to someone today about doing one in Greek, possibly doing one in Italian. Jim, if you speak any other language, you are more than welcome to do that as well too. So anyway, speaking of Jim, to get to the point of what we're talking about today, we talk about a lot of different things in our community, from operators to networking, data resilience, data gravity, pipelines. We've got lots of stuff going on. But I think, and this is what I talked about with Jim when we met last year, is that very frequently, there's a day 1 Kubernetes, then day 2. I'm curious to hear more from Jim exactly what that involves, exactly what that entails. But very often we might forgetting about some really, really important things that can become extremely problematic if we don't take care of them. It's not that we're trying to clip anybody's wings, so we want to stick to best practices, and that's exactly where Kyverno comes in regarding policy, right? So we say, honesty is the best policy, transparency. Jim mentioned in a previous podcast, talking about some of the founders of Kubernetes, that Kubernetes is a toolkit. What you do with that, how you take care of it, how you clean it, how you organize it, how you configure it, how you intend to use it is really up to you. So that's exactly what we're going to be talking about. There are a couple of questions that I'm excited to ask, but we're going to get to those probably a little bit later. If you have questions, please feel free to put them in the chat. You can also leave them in our Slack. You can put them on Twitter, whatever you want, but the best place to do it here is the chat. That being said, I would like to introduce Jim Bugwadia, who is our speaker today, who is simultaneously involved in Nirmata as well as Kyverno. We're just talking about how 2021 is a very busy year for all of us. In Jim's case is no exception. Jim, thank you very much for being with us today. Can you just tell us a little bit about yourself, how you got started in tech, how you got started in Kubernetes, what Nirmata is, and what we should know about basic things about how Kyverno got started?
Absolutely. Thank you, Bart, and thanks everyone for joining. So I'm Jim Bugwadia, like Bart said, co-founder, CEO at Nirmata. Yeah, so certainly, tech was something that I just stumbled into, a long time ago, and started building software, I guess early in my college days, and just fell in love with that. So all through my career, I've been in different various software companies, working on different projects where we have looked at management planes for in like data networking, telephony, wired wireless communications, those type of domains, right? And what my co-founders and I at Nirmata, what we saw back in 2013 is that every enterprise was gonna, as they were adopting cloud computing and the new way of doing infrastructure, there was this need for better ways of managing software. And that's the whole thesis. That's what we do at Nirmata. We provide a management plane for Kubernetes clusters and workloads, which is cloud-based, can be accessed as a service. And Kyverno is a spin-out actually from the Nirmata platform. So one of the basic principles when you're managing things at scale, you kind of touched on day 2 operations management, right? So any system, any plan that you're rolling out, you typically can organize as a day 0, day 1, and day 2 focus. Day 0 is when you're actually doing the plan, when you're looking at the various aspects of what you want to build. Day 1 is the actual configuration. And day 2 is the ongoing operations and management. And what we see in Kubernetes today is there's several different ways you can spin up clusters, right? You can bring up a cluster using Minikube on your laptop. You can use Kind. You can go to any cloud provider, spin up a cluster. So the day 0, day 1 parts are fairly I guess widely available and fairly easy to do. But once the cluster is up, how do you tackle the ongoing operations and management of that cluster? And in many enterprises, it's several clusters, dozens of clusters, hundreds of clusters, even thousands. So managing those at scale is a very complex endeavor. And that's where, what we do at Nirmata helps, as well as Kyverno as a policy engine, like you mentioned, enforcing best practices, validating configurations, that becomes extremely important.
Mm-hmm. With this in mind, and from co-founder's experience, we have two different names. What's the meaning of Nirmata and Kyverno?
Yeah, great questions, right? So Nirmata is an Indo-Aryan word for architect. And what we do, and it also sometimes, if you like Bollywood films or Hindi films, you will see Nirmata at the end as director. So it kind of means orchestration or direction. And what we do is cloud-based orchestration of clusters. So that's how the word Nirmata fits in. Kyverno, on the other hand, is a Greek word. It means govern, to govern, and that's where if you look at governance for Kubernetes, that's what Kyverno as a policy engine does.
All right, very good. Always nice to have a little bit of etymology. We already had a question from somebody in the audience. If the recording will be shared, don't worry. We upload all the videos from our meetups onto YouTube, so you can check out our YouTube channel. And whenever you get a chance, you just type in Data on Kubernetes Community. That will be there. All right. With that being said, in terms of context, I guess we've got a little bit of an understanding about how we got to this point. Could we, let's jump right into your presentation then, so we can hear more about how Kyverno works and what we can expect from it.
Yeah, absolutely. So I'll start off with a few slides, and definitely as questions come in, happy to answer those. And what we will also do is we'll do a live demo and see Kyverno in action itself, right? So first off, I think we talked a little bit about why Kyverno and what Kyverno is, but so it's a policy engine designed just for Kubernetes. It leverages, because it's built for Kubernetes, it's able to leverage all of the resources, patterns, the idioms sort of built into Kubernetes itself. Say, for example, if you have controllers, pod controllers and pods, if you have finalizers, Kyverno is able to recognize these type of patterns and intuitively create a user experience which is very seamless for a Kubernetes administrator or a Kubernetes user. So backing up a little bit and understanding why policy matters, right? And why would you even consider? I mean, Kubernetes is extremely powerful. You can do a lot of things just through its declarative interface. But it's important to understand how the Kubernetes API itself is designed. So you may have heard that Kubernetes is declarative in nature. And in programming, there's two ways you instruct systems to do something. You have a declarative approach, or you could have an imperative approach. Declarative means you're defining the end state. You're defining the goal of what you want the system to achieve, and the system will accomplish that for you. So Kubernetes operates in that manner, where you are saying how you want your pods to behave, how you want your workloads to behave, what you want to execute, and then the system, the controllers built into Kubernetes, work very hard on our behalf to make that a reality, right? Imperative, the other style, is where you're instructing the system what to do step by step. So you would say something like, place this pod on this node. And Kubernetes doesn't operate in that fashion, right? You don't tell it, you don't instruct it, what to do. You're just declaring the end state that you want. So it's important to understand that Kubernetes APIs are declarative in nature versus imperative. But what that also means is once you have to specify the end state, typically there's multiple concerns in terms of the end state. There's the developer view of things, the ops view of things. And then there's also another challenge that we see with declarative configuration is that there's just an explosion of things you want to configure, right? Because you want to be very granular and precise in terms of state. So this is where, although as powerful as Kubernetes is with the declarative configuration paradigm, it also sometimes is perceived as complex because there's a lot to configure. So policy management tools can really help with this by separating the concerns for what operators want to see as best practices for their cluster, and if they want to enforce certain guidelines or rules, and then having developers just focus on the configurations that they care about. And then also policy management tools can make sure that any best practice configurations like pod security or other configurations are well understood, well enforced, or either even validated, and you can report on these. So it becomes extremely powerful, extremely handy to have as part of your toolbox when you're looking at managing clusters. So with Kyverno, we've taken the same approach that Kubernetes does with configurations. So much like Kubernetes pod configurations or any other configurations, policies are also declarative. You can use the same tools that you use to manage Kubernetes YAMLs, like with GitOps, with Customize, with kubectl, any of the best practices you follow for your entire CI/CD pipeline and Kubernetes management. Now you can start treating policies as Kubernetes resources itself. And with Kyverno, what it allows you to do is you can validate configurations. So you can make sure that configurations are compliant to what you want, as well as you can mutate and generate configurations. So you can change things on the fly. So if you want to set certain defaults, certain environment specific data, you can do that. And you can generate new configurations. For example, when a namespace is created, you might want to generate a default network policy or even a default storage class for that particular namespace, which binds to that, what the user is trying to do. So lots of interesting patterns, and we'll take a look at some of these live and see how they work. But that's at a very high level what Kyverno does. Now, one thing you might have heard of OPA or OPA, Open Policy Agent, as another policy toolkit. It's an extremely powerful toolkit as well, and certainly if you're looking at policies for Kubernetes, I recommend checking out both Kyverno as well as OPA and deciding which one fits your needs the best. So OPA, just a little bit about its history. It was designed as a general purpose policy toolkit. It uses a language called Rego. And here I'm showing an example of what the same policy looks like written in Rego on the left, and then written in Kyverno on the right. So the Kyverno policy on the right matches more or less what you would expect in a pod definition. This particular policy is enforcing that every pod uses, a read-only root file system, which is a security best practice. And you do that by configuring the security context within a container and setting this attribute called read-only root file system to true, right? So fairly simple to do, again, through this declarative configuration. But if you don't set this as a default, this could be overlooked, right? So with this policy, you're requiring that every pod has this setting. And you can do, again, like this is showing, either with OPA, but OPA with Rego, again, the value proposition there is you can use that same policy language, not just in Kubernetes, but other systems as well. Whereas, with Kyverno, it's just designed for Kubernetes. So depending on what problem you're trying to solve, both projects are CNCF projects. Both projects are maturing, and OPA is it started earlier than Kyverno, so it has some traction and is to some degree fairly well known in the community. But certainly both are capable of solving some of these problems. Kyverno, like I mentioned, goes a little bit further, also does generate and other things which you would want to see in your cluster. So diving in a little bit deeper into what exactly a Kyverno policy looks like, and we'll see some of these examples live as well. So every policy has a set of rules, and they are declarative again. And in the rule, you're saying what you want to match. So like that could be criteria like the types of resources, like a pod or a deployment, stateful set, things like that. You can match things by names using wildcards. You can use label selectors. So again, using Kubernetes best practice. You can have namespaces. You can even do things like match with user roles. So if you want a policy to only apply to a certain group of users, you can do that. But then if a cluster admin is taking an action, maybe you don't want that policy to apply. So that provides a lot of flexibility. All of these match and exclude conditions is how you would select which resources Kyverno is operating on. And then once you select the resources, you can write rules to either mutate configurations, validate configurations, or generate new configurations and new resources based on those triggers, right? So that's the high level structure which every Kyverno policy follows. And the way this works in a cluster is with Kubernetes, I believe it was like 1.15 or 1.16, where there was this concept of admission review request that was introduced. So Kubernetes is designed to be very extensible, right? So you can have custom resources, and Kyverno uses custom resources in Kubernetes to introduce this concept of policies. But you can also write admission controllers. And that's a very powerful concept where every operation in Kubernetes goes through the API server, and an admission controller acts as almost like a gatekeeper to some degree to say which API requests are allowed, which API requests can be blocked based on your policies, and if you want to trigger some additional behavior based on those API requests, right? So as this diagram shows, what happens is once Kyverno is installed in our cluster, it will receive every API request that goes to the API server, and then it makes a decision on what to do with that request based on the configured policies. If you don't have any policies configured, nothing happens. Once you configure some policies, Kyverno will be able to validate your configurations. It can even block insecure configurations or things you might not want to allow in your cluster. And you can mutate things. So you can add labels, you can add certain attributes, things like that, as well as you can generate brand new objects if you wish for your users. And the output of this becomes policy reports, which are also available inside the cluster. So you can see who's compliant, who's not. You can get events from your cluster event logging. So you have a full trail, an audit trail of what exactly happened. And then within the resources itself, Kyverno will also update resources, add some metadata to know which policies have been applied. So that's a very high level view of what Kyverno does, how it works. And we'll dive into some more examples, but let me pause there and see if Bart or anyone else has any questions or any thoughts so far.
Now, I really liked what you mentioned in the beginning. One of the first slides, you were talking about how, we have people that are going to be working with this tool who perhaps come from different backgrounds. Mm-hmm. If you're someone who, as a co-founder, CEO, very much in the middle of all these different profiles, who would you say, maybe different profiles have different challenges, whether they're a DevOps background, software developer background, infrastructure, et cetera. Is there one particular group that seems to have more difficulties culturally adapting to using Kyverno, or would you say that each group might have specific things that take a little bit more time to understand?
Yeah, that's a good point, and certainly even if you kind of broaden that question to Kubernetes itself, right? Kubernetes has several personas. There is the cluster admin, there's the system admin persona that's managing the cluster, but then you also have experts in networking, in storage, and data management, and then you have the layer of workloads on top. So if you're running like a database, on Kubernetes, you will of course have your, somebody who's very familiar with that database itself, who wants to manage and operate it. So Kyverno is mostly designed for the cluster admin because they're the ones who are setting the policies, managing the policies. But you can also have policies at a namespace level. So if as a namespace owner, you want to specify certain policies, you can, right? So broadly speaking, you can think of, with anything in a Kubernetes cluster, you can think of the system layer. You can think of a services layer where you're providing some shared services. Like a great example would be something like OpenEBS. If you install that now to provide native storage within your cluster, that becomes a shared service across all workloads. And then you would have the workload layer where you're managing independent workloads. So Kyverno can operate at all of those layers, but mostly we would see cluster admins setting the policies that are cluster-wide. And then if you want to include certain policies as part of your workloads, you would have them within a namespace itself.
Awesome. Good. We got a question here from the audience really quickly. What does eliminate day 2 Kubernetes challenges specifically refer to?
Yeah, so if you think about again, like the whole journey of somebody deploying and operating Kubernetes clusters, and especially once it gets to putting those in production. So some of the main challenges there we see are this sort of having that separation of control concerns between developers and operators, each role, each persona being able to do their job as efficiently as possible without having to deal with all of the machinery or all of the concerns of Kubernetes. So one of the things Kyverno does, and also what we focus on heavily at Nirmata, is that elimination of complexity, where to make it simple for workload owners to go in and deploy something, run something, and they're very, very easily told, as you'll see in some of the demos, it just tells you that, okay, this configuration is not allowed. Here's what I need to do to be compliant, right? So I don't need to know all of the details about Kubernetes and learn all of that if I'm just trying to deploy my pod or deployment. Just tell me exactly what I need to fix in order for it to work. Much like if I'm writing some code, the compiler's telling me what I need to do to write correct code, right? So it's having those guardrails in place is really what we mean by eliminating that complexity, and then allowing the flexibility for your admins to specify those guardrails, because each organization, each enterprise is different, and it's not something, some policies may be well known and well adopted within the community, but this needs to be very customizable by the administrators as well.
I think it's a great point, and something that to steal or to remind people that there are some great podcasts of Jim out there. And one of the podcasts that you talked about, like you said, when we were talking about complexity, but how can we make Kubernetes a bit more boring? That it doesn't mean that it's not going to be exciting, but to be in a space where it's not so unpredictable and there's more of an element of control. And once again, as the name suggests, governance.
Right. Yeah, absolutely. Yeah, and being, I think all technology sort of goes through this life cycle, right? Where, of course, as early adopters, as being sort of, folks in the tech space, we get very excited about things like Kubernetes or Linux kernel, features, etc. But to end users, they shouldn't have to care about this, right? They want to deploy their applications. They want those to run well and make that as easy as possible for them.
Very good. Okay, keep going.
All right. So yeah, just diving in a little bit deeper into what a policy looks like. So this is an example of another policy. Here we're saying root user is not allowed, and just kind of going through like what I mentioned earlier. So if you look, starting at around line 8 is where the match clause is, and there we're saying, okay, this policy needs to match a pod. And then the rest of the policy, like starting from about line 14, is where we're doing a validate the body of the policy itself. And what that's saying is, if I see any pattern, like any one of these patterns, and the first pattern here in the list is if I see security context being defined, I want to make sure that run as non-root is set to true. Or if I see containers with a security context defined, I want to make sure that run as non-root is set to true. So basically what this policy is going to say is one of these has to be set. I have to enforce that my pod is running as a non-root user. And the reason why running as a root user is bad is if your pod's running as root, and let's say there's somebody with malicious intent who has access to that pod, they may be able to get root access to your host. And once they have root access to your host, things can spread from there, whether it's malware or if they're trying to, access other systems, things to that nature. So it's very important in production that you're running pods with the proper security configurations But again, this is not necessarily something that every developer has to be aware of. Now you can enforce that with the Kyverno policy or with with other constructs to just make sure that your workloads are compliant to these settings, right? So fairly complex again internals, but it could be very simple for users, and we'll again see how this applies in action. So going again a little bit deeper and looking at the mutate policies, right? So like I mentioned, Kyverno can validate things. We saw that in the previous example. But what about when you want to change things? So with that, Kyverno has the ability to check. Like here are some examples. Like first off, in this the example on the top is using a format called it's an actual RFC, which is a standard implementation of something called a JSON patch. And what that does is you can specify a particular path. You can say, if I have a template with init container and it has the first init container, I want to make sure I'm injecting this particular container into my pod. So that's what the first example at the very top is doing. The next example is doing something slightly different. It's saying, if I have a port which starts with the name secure, I want to make sure that the port number is set to 6443. So of course, this could be any number you wish in your policy, but just as an example, it's doing a simple conditional logic to make sure that the port number is set to what it should be. And the next example is similar, but what it's saying is if the user hasn't specified a port number, I want to add that port number in, but if they've already specified one, we will use whatever the user provides, right? So again, very simple without having to, kind of learn any complex coding or anything like that. Simple way of defining policies and using policies, through this declarative approach itself. So there's more features in terms of how you could validate things. Like for this example is just saying, if I want a label called app in every workload, it would be as simple as writing these few lines of YAML and applying that, and that's going to enforce that that label is present. And of course, there's several other operators and things you can leverage, right? And finally, like an example of a generate policy where you can do things with Kyverno, like you can generate resources. Like if a service is created, maybe you want to generate some resources for that. One great use case, and there's a blog post on the Nirmata site on this, is there's a toolkit called Valero for doing backups of namespaces or backups of your cluster configuration. It also does volume snapshots and can back those up. So with that, what someone in the community has done is they have used Kyverno to, if you annotate a namespace or if you add a label on the namespace, it will automatically generate a Valero backup policy for that particular namespace. So this gives a very, again, easy way without a developer or a workload owner having to know, the details about how backups work or how they're implemented. All they're doing is adding a label on their namespace to say, this namespace requires backups, and then everything else is automated for them through Kyverno and through a controller like Valero in this case, right? So good example of using, generate policies. This example that I'm showing on this screen is to generate a default network policy. So network policy is a Kubernetes resource. It works in conjunction with the CNI, the Kubernetes networking interface plugin. So if you're using something like Calico or KubeRouter, that will enforce the network policies. But this declaration, this configuration says, in my namespace, by default, deny all ingress and egress traffic, and then allow the workload owner to expose the routes, to expose the ports that they want in their namespace itself. So again, very important to do if you're running production clusters, because you don't want to allow traffic into your workloads. It's kind of like setting up a firewall for your application itself in a very simple manner. So when Kyverno runs inside a cluster, and if it's finding any violations, there's also a built-in policy report, and you can see this directly through kubectl, like this example shows. And it will show you the pass-fail, if there's any issues to look at. And then you can quickly grep that in your cluster, see if there's any problems, where the errors are. There's also, again, someone in the Kyverno community just contributed a dashboard where they're taking this data from the policy report, pushing that to Prometheus and showing that in Grafana and Loki to be able to log all of the policy violations and kind of show some trends for that. So very cool, that to see like all these community contributions and how folks are using Kyverno in the real world, and also contributing back to the project to extend it and to grow its capabilities and features. Yeah, so with that, I can shift to a live demo. But before we go there and talk about some use cases for data and storage, let's see if there's any other questions or thoughts.
Oh yeah, we got a question right here. So can you point out in the Kyverno syntax what differentiates between workload versus namespace administration?
Yeah, so one way of kind of thinking of it is when you're creating a namespace, right? And I think one of the things we're, in the multi-tenancy working group and some of the other Kubernetes sessions is a lot of discussions about how to take a cluster and allow different, application owners or different teams to share a cluster. And there is some complexity with that, but there's a lot of efficiencies, there's a lot of benefits to sharing clusters for a team, right? So the namespace is really a segmentation boundary built into Kubernetes to allow that secure sharing. And here, what the pattern that we typically see is you want to provide a team a namespace within an enterprise, and they can run one or more workloads in that namespace. The best practice here would be to run a single workload within the namespace, but very often, just because of organizational reasons and other challenges, you may see multiple workloads running within that namespace. So the namespace really, with the Kyverno syntax, you would be targeting, the actual rule to match that namespace. Like I mentioned, you can even write policies that only act as namespace resources. But then if you're targeting a workload, you would be matching that using the image name of the workload or the application name or some other constructs in your match and exclude, right? So that's how you would distinguish between the two constructs.
All right. And one more question. Which is the most common policy violation that comes up?
Yeah, so pod security is definitely a hot topic these days, and there are a certain set of rules. In fact, I'll show, as one of the first demos we'll do, we'll go and kind of look at some of the pod security rules, but something just as very basic, like I showed an example, running pods with root access, right? That is a very and it's an inadvertent, it's a very simple mistake to make. You go grab a Helm chart or you run something from Docker Hub. You never know what you're getting, right? And if that pod has been built correctly, the container is operating as a non-root user, it may not have been configured correctly. So and a Helm chart may have thousands of lines of YAML. No one's going to sort of expand that out and read through that. So it's important to have some way of immediately knowing that, hey, this workload is not configured for production standards. It's fine if you're running that in your local cluster or in a test cluster, but before you move to production with that workload, you would want to fix these things. So certainly, pod security is one of the biggest areas where we see policies being applicable. There's a lot of, and you might have heard, in the community, there's a lot of discussion going on. Pod security policies, PSPs. There is a construct in Kubernetes called pod security policy. Those are being marked for deprecation in version 1.21, which is going to be released in the March-April timeframe. And they will be officially removed from Kubernetes in version 1.25. So there are, the special interest groups, the other folks in the Kubernetes community there are folks looking at how they can replace pod security policies with some other constructs inside. But currently the two available, options really are, you can use Kyverno as a PSP replacement. You can also use OPA Gatekeeper, the other policy engine I mentioned. They have a set of policies they've built and they make available also to replace the same constructs that pod security policies provide. One of the advantages you get with Kyverno is there's a lot of flexibility in even mutating workloads, and that helps and with some of the generate policies.
Very good. Perfect. Let's jump into the demo.
Yeah, so just some use cases that we'll look at from the storage side of things. I have a sample which like something as simple as making sure we're restricting the host path, for a pod, right? So let's say you want to run a pod, but you don't want somebody to mount, like something like, var or etc, folders on your host, but you want them to only use certain directories. We'll look at a policy for that. We'll look at policies for restricting different volume types. We'll also look at policies that mutate workloads based on the type of volumes to add labels, things like that. Yeah, and in general, some of the other use cases that we see, like which are becoming fairly popular, everything from things like sidecar injection into containers, auto labeling your workloads, managing multi-tenancy through namespaces and default configurations, having fine-grained RBAC policies, right? So being able to create rules for who can use what automatically. Those sort of things are also becoming very popular. But all right, let's jump into some of these use cases. I'll show. In fact, let's start with pod security policies, right? Because that's something everybody should have configured on their cluster if you don't already. So we'll start with what that looks like. So let me grab a shell and I'll expand this a little bit. So hopefully it's clear to everybody. And so if I look at my namespaces, I'm just running, this is Docker for Windows. I'm running that on my, local laptop. I have a few namespaces. I have a test namespace and Nginx and just some defaults, right? So I don't have Kyverno running yet. So let's go and install it. So to install Kyverno, I'm going to go to the docs and in here, just go through the introduction. And in the quick start, there's a handy one-liner. So there's a Helm chart you can use to install, but I'm just going to install it directly from the YAMLs. So I'll copy this and we'll go ahead and apply this to install Kyverno in our cluster, right? So what it's going to do, it pulls in a bunch of stuff. It's telling me it created some custom resources. It has some roles for Kyverno. And now if I look at my namespaces, I should see the Kyverno namespace. Whoops, wrong window. Yeah, which is active for about 13 seconds, right? So great. So we got that. And if we look in that namespace, let's see what's running. We should see at least one pod running and it's running. Everything looks good. So fantastic. But at this point, if we do, get cluster policies, we should see there's no cluster policies found because we haven't installed any, right? So Kyverno is running, but I don't have any policies. So let's actually, since we were talking about pod security, let's look at what it takes to install those. So I'm going to go back to the Kyverno website, click on policies, and you see there's 3 sections here. There's pod security policies, there's best practice policies, and other policies contributed by the community, and some other policies which are interesting to look at. But we're going to click on pod security for this demo. I'm going to go and again, it tells me, hey, these policies are based on these Kubernetes standards. If we look at that link, it tells us a lot of information about what pod security is, how to organize things, what controls you want in place. So there's all these fields, right? So there's a lot of stuff to, and in fact, for storage, You can see it's saying don't use any of these volume types because these are all now marked for deprecation. They'll be replaced with CSI, controllers for a lot of these. So, lots of different policies to kind of look at and think through. But going back here, what it's saying is, hey, to apply all pod security policies with customize and Kyverno, just run this one line command, right? So let's do that. So let's go back to our cluster. I'm going to run that one command. And what this is doing is it's running customize, it's pulling from the Kyverno repo, and then it's just applying it to my cluster. So this will take a few seconds because it'll pull down quite a few policies from our repo. And once it pulls those, it will apply customize to combine them all into a single YAML. And at that point, it should start applying the policies. So good. So I see a bunch of different things created. And if we run that same command before to see cluster policies, now we see that we have a bunch of different policies installed, which are checking things like host path enforcement. It's also checking the volume types that we were looking at, several aspects, and all of these are running in enforce mode. So what enforce mode here means is that the Kyverno will block invalid configurations from being admitted into your cluster. If this were running as, instead of enforce as audit, it would mean that there's a report produced. In fact, if I have any existing, workloads in my cluster, what I should be able to do is do something like get policy reports. And if I do -A, I will see that Kyverno is automatically generated for my Nginx namespace. It said that 34 rules passed and 1 failed in that namespace. So it scanned that workload and told me that, hey, something's not quite right. And if I want to go look exactly at what that error is, there's a one line, again, a command I can use. If I go back to documentations, look at policy reports, I'll just copy that from here. So it's telling me, so we saw this policy report here. And if I want to view violations, I can just describe the policy report. And then I'm going to grep for everything which has a failed status. So let's run that to see what exactly is wrong with that Nginx. So I'll clear and let's try and copy that again. Seems like it did not catch the command. So you're, oops, so it's actually, instead of default, I think it's namespace Nginx in our case, right? So if we do that, let's check the report name again. Okay, I think we have to just give the namespace name because this was in a specific namespace. There we go.
There we go.
So now we're seeing that here's the validation error, and it's telling me, like I said, a very common mistake is you run a container and you don't realize that it's actually running with root privileges, right? So that's exactly what it's telling me in this case for my particular workload. But let's try and do something more intrusive with our cluster, right? So there's this great site that I saw and we kind of used for testing. It's actually maintained by the security company called I guess Bishop Fox is the company name, but they have this site called Bad Pods, which it's like pods which are misbehaving. So you can go look at all of these YAMLs they have for bad pods, and you can and actually they even have deployments and things like that. So this one, everything allowed, like it says, look, you're leaving all doors wide open is what they're visually telling you, from your host path to your network to host IPC. So pretty bad, right? And what we'll do is we'll actually go, let's get instead of just grabbing a pod, this time I want to run a deployment. So I'm going to take this raw YAML, which is saying, hey, you're running a pretty misconfigured deployment, and I'm gonna say kubectl. Let's do create -f, and we'll give it that particular YAML. And what we see is Kyverno immediately rejected it and is telling me why it rejected that particular pod, right? So it's saying you can't use host path volumes. That's a bad thing. You can't run with privileged mode. You can't run as root. So it blocked it because of those 3 violations, right? So pretty easy way to get the equivalent of pod security policies, and with by installing the set of commands there and the policies that I showed. And I'm just going to remove them for the other demos, but what I wanted to show is how simple it is to get your clusters to a more secure state, and it's not going to impact your existing workloads, because Kyverno is not only going to operate on once things that you're like new workloads, and will block invalid configurations, right? Okay, so that was on pod security, but let's go and look at some of the other policies that I was talking about. And I have some of these in my Visual Studio Code over here. So actually, we'll go look. We can start with this host path one. Let me make this, see if I can make this bigger. Okay, there we go. So this policy, what it's doing is it's checking and making sure, oh, so this is actually a pod, but what I want to see is this policy itself, right? So here's an example of where I want to make sure that in my cluster, if someone's using a host path volume. So first off, using host path is not a great idea. If you can prevent it, you should. But if a pod is using a host path for some reason, some valid reason, maybe you want to restrict it to certain paths on your host, right? You don't want it to get access to like root. You don't want it to get access like root here being slash, and you don't want it to get access to some system folders and things like that. So I'm going to install this policy, and then we'll try and run a pod, which will use different host paths, and we'll see what happens with that. So just to install this, I'm going to say kubectl apply -f, and this policy name was policy restrict host path. All right, so we will apply that policy, and now I want to run my pod, which is trying to use a host path, right? So immediately what we see is Kyverno again denied that request and said, hey, you're using a host path, fine, but make sure you're starting your paths with either temp or user temp, right? Because that's what I want to allow. So let's go back to our pod and actually change it to see what happens now if we, instead of /data, I want to do /temp data, right? So if everything works correctly, that pod should be allowed, right? So let's just quickly try that. And if I apply it, sure enough, now I can see I have that pod. And if I do get pods, it's running, right? So I'll go ahead and delete that, but that shows you how Kyverno can now enforce and block. But of course, if you're, everything's compliant, it will allow that workload to go through. So quick example of that. One other example I'll show, and then we can do some more Q&A, is, so this is a good one, right? So if you have, or actually, let's go to this policy. So this is in our best practices library, also in online. But what this policy is doing is it's saying, if you're using either host path or you're using an empty dir, you want to make sure that this label is set in Kubernetes. Now, what does this label do, right? So if you look at it, it's cluster autoscaler, kubernetes.io, safe to evict, true. The way, in Kubernetes, there's this concept of autoscalers and node autoscalers. And as autoscalers, are up, what they are responsible for doing is when you run out of capacity, if you have pending pods, they will add nodes. And when you have free capacity, they will try to drain nodes and remove nodes. So very powerful concept if you want to use elasticity for your Kubernetes clusters. But if you end up using a pod which has an empty dir, which creates a bind mount on the host, or if you end up using a pod with a host path, Kubernetes cannot automatically evict those pods unless you're putting this label to say, hey, my workload is safe to evict. Because although I'm using a host path, I don't care if Kubernetes kicks out this pod, I do want to drain my node. So again, lots of details here going, kind of proving what we were discussing with the declarative nature and the perceived complexity, but extremely powerful, concepts, right? Things you can manage very easily by specifying a few lines of YAML. So now what I want to do in this cluster is I want to make sure that if some user is running path, any pod with empty dir or host path, I want to make sure these labels are enforced or automatically injected so that my autoscalers can work correctly, right? So let's go ahead and add this particular policy and see what happens. So if I go, and in this case, I want policy, I want to add, add safe to evict. And then I'm going to create that same, host path pod again, and we'll see what it has, right? So we'll do create -f and see that host path pod, it got created. And if we do now, let's say kubectl get pod -o YAML, and I'm going to pass this to kubectl. So by the way, if you looking at a lot of YAMLs, there's this great plugin called kubectl neat, which will tidy up your YAML outputs for you and remove things like the managed fields, etc., which typically add a lot of clutter. So here, what we're seeing, in the YAML output is what the important thing is. This annotation has been added based on our policy, right? So the policy recognized that we're running a host path and automatically injected this annotation for us, which lets Kubernetes autoscalers do their thing and operate correctly. So again, good example, simple example, but powerful one to show that separation of concerns. Developers should not have to worry about all of this complexity. They are running their workloads with the configurations they want. And then based on these policies, cluster admins can make sure that the right security concerns are in place, as well as make sure that other things like these autoscalers or other storage concerns, etc., are met, right? So that's I think a quick sample. Just want to also kind of mention again, Kyverno has a fairly active community, so just come ask questions in our Slack. We also on our GitHub, if you check out the project there, make sure if you have any like feature requests, if you're thinking of any policy ideas, there's a discussions section. There's also ways to submit ideas for new policies. So we'd certainly love to hear from everyone and hear about ideas for how Kyverno can help with data management, with things you're looking to do within that domain. So let me pause there, see if there's any other questions or any other topics.
I think it's a perfect segue into. I would like to know what have maybe been some of the surprises for you once when you decided to open up Kyverno, create this community, get feedback. Mm-hmm. What have been some of the things that you maybe we had never thought about that, or this has been really interesting to see the direction that the community is taking it. What kind of things have you noticed?
Yeah. No, it's amazing to see the enthusiasm, the support we're getting, and just folks just pitching in and building together, right? Because I think all of us in the tech space, what draws us to software and technology in general is we love building things and creating things. And I think just shaping Kyverno, making adding features like I mentioned, the dashboards with with Loki and other tools, being able to make things even easier. And the suggestions we're getting, we have folks jumping in, helping in with documentation, making it easier to contribute policies. So it's just amazing to see that. And just CNCF in general, all of the communities are super friendly, very welcoming and inclusive. So it's great to just dive in. And one of the things we've also seen is just the people coming into the project, looking at things marked as good first issue, and just jumping in, right? And I think really, like, we're seeing a really good diverse set of skill sets. So there's no question or issue which is too small or too big. It's just getting started and contributing to open source and building something that you're seeing others start leveraging quite easily, right? So that's what's been most amazing. Of course, the first release, once we got adopted as a CNCF project, the first release to put out, like with all the different types of tests, all the different users and use cases that came in, that took us quite a while to get some of the things in order. But now we have a fairly well organized process where we're pretty active in putting out releases every few weeks, patch releases, and then with major features and other things, where we have community meetings, we have open discussions on these. So just great to see the ideas, the things coming in, and how the project is continuing to shape up and build.
Mm-hmm. With that in mind, and because we are talking about some issues related to security here, I heard somebody one time tell me, there are two kinds of companies: the ones who know they've been hacked and the ones who don't. To what extent do you think that's true? And also, I think it's been interesting in the last 6 months to a year, we've seen now the certification rollout for security related to Kubernetes, alongside developers and Kubernetes administrators. What role does policy play in that? How does training relate to this? Where do you see this in the sense of, are companies being proactive enough about this? Or is it, we've had an incident, now we're going to, hire some consultants and get everybody trained? How can we make this, a part of an integral part of culture from the very beginning? In the same way that when we talk about, cost saving, cost optimization, don't, implement this stuff when it's only become a problem. Have it from the very beginning. What do you think about that?
Yeah, great point. And I think just our, the community in general, and especially for those building technologies, I think we need to make security easier, right? Because there's a lot of security is just overly complex today, and with some of the things, and that was our big motivation also in introducing Kyverno, making it open source, making it part of the community. Every cluster should be. There's no reason why you would not want to run security best practices as policies in your cluster. As we saw a few minutes ago, with a couple of lines of kubectl commands, you can get to a much better, much improved security posture, almost like with very little effort, right? So there's certainly training is and awareness is a big part of it. I agree, and I think it's having tools that make this simple, rather than make this seem so complex that you want to kind of defer it and say, I'll get to it later, but right now I just want to run my application, right? I don't have time to understand all of these other things, right?
I think it's a good point. The same way with policy, when we talk about government, how many people read a ballot proposition or, a bill that's going through Congress, and we get angry at our politicians for not reading this when we ourselves wouldn't do it either. Sometimes you have can we get a 500-page document into a one-pager with 5 bullet points? I think there's the kind of art here, right? Is making it, simplifying seemingly complex topics.
Yeah, no, that's an extremely good point. And this discussion, there's some interesting, Twitter threads and et cetera, also on Kubernetes itself, right? And a lot of people say, why is Kubernetes so complex? Well, it's complex for a good reason. It solves a set of complex problems, right? So it deserves to be complex, but doesn't mean if you're using some aspects of Kubernetes, those should be as simple as possible, right? So I think balancing that simplicity and complexity and making something complex simple to use is what we should all strive for, as we're building technologies.
Good. In terms of next steps, obviously you've got a lot of stuff going on. Is there anything that you've got in the pipeline, thinking about maybe some additional features or other projects that you have in mind?
Yeah, so certainly lots of interesting features coming out. We just rolled out a way to make API calls from within policies. So now you can look up external data sources within the cluster, but you can call the API server, you can get access to other resources. We're also making it, more and more easier to do anything standard that you want to do with policies. We continue simplifying and making easier. There's also a proposal to, allow, some programmatic policies like with some JavaScript declarations, things like that. So for more complex logics, you can kind of fall back to writing some custom code when needed. So this way, you can kind of address all of your policy use cases. And then finally, another exciting thing is just the collaboration we're seeing with other CNCF projects. Like we are working with Flux, with Cert Manager, with other projects that want to incorporate policies as part of their projects itself. And that's where I think there's also good opportunities to communicate with or collaborate with the data and storage community and build a set of default best practices for data management with other open source projects focused on that area.
Yeah, I think no one, from my involvement getting more and more into stuff with the CNCF, just being such an open space with people so excited to collaborate. Sometimes the difficult thing is, all right, I can't be in 15 projects. I can probably only be in 2 or 3. But I think it's a great space to be in. So it looks like things are going very well. That being said, we are getting towards the end, and we have a tradition that in every one of our meetups, we have an artist who's doing a simultaneous depiction of all the things that are being discussed. Gorka, can you share my screen? So let's see how well Angel did. All right, Jim, I think you can see that. So we have some of the different topics that were being mentioned, some of the different angles that were being explored. So hopefully there was a lot that was discussed. So
wow,
I think we have enough for quite a few different things, but we always like to get an artistic depiction to be able to show side by side the sort of journey we've gone through, visually speaking. That being said, you already saw Jim point out the website for Kyverno. It's extremely accessible for anyone who wants to take a look at that. We'll obviously be leaving links for that as well too in our Slack, on Twitter, on LinkedIn, etc. This video, if anybody arrived late, will be available in a couple of days on our YouTube channel. I am pretty sure we're going to be having you back, Jim. So we'll have to be looking at calendars to find when we can have you on. I was saying before we started, have you ever thought about teaching?
Not well, not at the moment, but certainly down the road, obviously. And we do work with one of the amazing things also happening in the community is there's a lot of folks coming in as interns, etc. So certainly we're mentoring and helping with that, but I'll have to kind of keep that open as a career choice now.
Yeah. I mean, anyway, there's always time. There's always options. Thank you very much, Jim. It was an absolute pleasure to have you. Looking forward to have you back on in the future. And I'm sure we're going to continue the conversation. We didn't have enough time to get to all the questions, so we'll be continuing the conversation in our Slack channel. If anyone isn't in there already, please get in there. We'd be happy to have you. So yeah, Jim, thanks a lot. We'll be in touch.
Sounds good. Thank you, Bart. Thanks, everyone.
Bye-bye.
Take care. Bye-bye.